Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Makri, and today I'm going to talk about experiment 7, Torricelli theorem. First of all, abstract. In general, the purpose of the experiment is to demonstrate the relationship between liquid exit velocity and its height in the container, as well as how to compute exit velocity using Torricelli theorem. By using a cylindrical tank with a drilled hole, a measuring tape, and a clay marker, Torricelli's law can be demonstrated. However, we assume that it is an ideal fluid, which means that the liquid is compressible and non-viscous and laminar flow. Next is objective. The objective of this experiment is to verify Torricelli's relationship by comparing measured and theoretical value of velocity. Next is introduction. Torricelli's theorem is a fluid dynamic theorem that describes the relationship between the speed of fluid flowing through an orifice and the height of fluid above the opening. Torricelli's law is useful in everyday situation. This theorem describes a clear correlation between liquid exit velocity and its height in the container. The theorem explains the relationship between fluid leaving a hole and the liquid's heights in that container. A soft drink bottle can be used to do a simple experiment to test Torricelli's law by puncturing the bottom with a small hole. The exit velocity reduces as the reservoir height reduces.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So the theory for this equation for this experiment is Torricelli's theorem. It's also called Torricelli's law, Torricelli's principle, or Torricelli's equation, that the speed of a liquid flowing under the force of gravity of an opening in the tank is proportional jointly to the square root of the vertical distance between the liquid surface and the center of the opening to the square root of twice the acceleration caused by the gravity 2g, or simply be 2gh power of 1/2. So the speed of a portion of water flowing through an opening in the tank a given distance below the water surface is the same as the speed that would be attained by a drop of water falling freely under the force of gravity alone, that is neglecting effects of air to the same distance. Okay, the speed of flux is independent of the direction of flow at the point of the opening. The speed is given by this equation, whether the opening is directed upward, downward, or horizontally. Okay, the velocity of non-viscous fluid flowing from a cylindrical tank can be represented by Torricelli's theorem. So the relation is V is equal to square 2gh, where the V is the velocity, h is the depth below the surface of the liquid, and g is the gravity of fluid. Okay, water stream from the hole is in horizontal direction, which can be represented by kinetic equation. For this case, the velocity v at any point can be represented by the time taken by the stream to cover a horizontal displacement of water, dx of the water stream, x. So this is the second equation, which x is equal to v initial times 2t, which is time. So for constant acceleration, equation becomes x initial minus x naught is equal to dx is equal to v initial delta t plus 1/2 a delta t the power of 2, where the a is 9.8 meter per second squared. So at initial point of v is equal to 0, equation 3 becomes dx is equal to 1/2 a delta t the power of 2. Okay, take note that the volume V and volume flow rate of the cylinder can be calculated from following equation, which V is equal to A HCW, or flow rate is equal to A to G HW, where A is area of cylinder meter squared, C is height of cylinder in meter, and W is width, which calculated in meter. Okay, we move to methodology for this experiment. So number one is the apparatus was set up based on the three different height of stages, which is 36.65 cm, 56.45 cm, and 76.15 cm. Second method is the cylindrical tank was filled with 5 different volume of water, which 2 liter, 1.75 liter, 1.5 liter, 1.5 liter, and 1 liter. Okay, number 3, the water was filled into the cylindrical tank and stopped at the desired volume of water. Number 4, the hole at the cylinder tank was covered. Number 5, the finger was took off from the hole. Then the maximum distance was marked by using the clay and record the time at the same time. Okay, the last one is the procedure was repeated by using different volume of water and at the different height of stages. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Umar Irfan bin Malta, and I'm going to present about the results and the discussion. For the results, we were given the tables, 3 tables. Table 1, which is the result obtained for height from floor to orifice, which is 36.65 centimeters. It is completed with the water flow rate and also the water velocity, and also the time taken for water to drain out and the maximum water trajectory distance. And for table 2, it is the result obtained from height from floor to orifice, which is 56.54 centimeter. And for table 3, the result obtained is for height from floor to orifice, which is 76.15 centimeter. For the discussion, we are asked to discuss 3 things. The first one is explain our selection on the dependent, independent, and constant variables. For variables, it is the maximum trajectory distance, which is x, and the time taken for water to drain out, which is t. While for the independent variables, it is the volume of water, v, and the height of orifice from floor, y. And the constant variable is the density of the liquid. And as we can see, the density of the liquid is the constant variable to provide a constant gravitational force for both equations. And to verify the Torricelli's relationship, we need to observe on the speed of fluid flowing from an orifice to the height of fluid above the opening. And for measured velocity, we need to observe on how the height of the orifice from floor affect the maximum water trajectory distance and the time taken for water to drain out, and thus we calculate the velocity of fluid. For the second part, it is to clarify on how you can relate the Bernoulli equation with Torricelli's law. For this case, you should show all the derivation and explain each steps. And as we can see, for the Bernoulli equations, we know that the initial velocity is 0, and the first point is taken at the liquid's first and second just outside the opening. Because the liquid is believed to be incompressible, P1 is equals to P2, and both can be represented by the same letter, which is P. Also, because the opening is really small in comparison to the liquid surface, V1 is considered to be 0. And because the density of liquid is the same at both places, G is believed to be almost the same. And as you can see in the Bernoulli equation, what we left is Z1 minus Z2. And Z1 minus Z2 is equal to the height of the liquid surface above the opening. And we know that H is V2 squared over 2G. And we get that the Torricelli's law is V2 equals to square root of 2GH. For the percentage of relative error for the theoretical and measured experimental values, we know that the g is 9.81 meter per second squared, and we use this value to calculate the theoretical velocity, which is 2gh, square root of 2gh, which we would get 3.86 meter per second, while for the measured velocity, which is s square root of g over 2y, and then we will get the value of 3.62 meter per second. And we know that from the experiment at v equals to 2 liters, y is equals to 0.3665 meter, and the the height average is 0.76 meter, and the s average is 0.99 meter. For the absolute error, we minus the measured velocity with the theoretical velocity, and we would get 0.24. While for the relative error percentage, which is absolute error divided by actual value times by 100%, and we would get 6.22%. And in the table, we can see that the average percentage error is the percentage of relative error over 5. We will get the average percentage error to be 28.83%. And the next table, we would get the average percentage error to be 28.62%. And for the third table, the average percentage error is 45.76%. For the source of error and the method to minimize the error, which is the platform surface of the cylindrical cylinder, it might be slightly inclined, and it might not be straight. And one of the methods to minimize the error is we put a level ruler on the surface to make sure that the platform is flat. And for the second error, a leakage may occur and around the opening of the cylinder through the space in between the fingers. And the way to minimize it is to use a stopper instead of finger to close the orifice. And for the next error is parallax error due to incorrect positions of the eye. And to minimize such error, we make sure that our eye is perpendicular to the reading scale. And the next error is the limitation in time response to human. The observer may not start and stop the stopwatch at the exact timing, or the observer may not point the exact maximum water trajectory distance. And the way to minimize the error is the reading should be taken repeatedly, so we can get the average value, and we will minimize the errors while taking the reading. The conclusion and recommendation: according to the calculations, the average error for different heights of orifice from the floor is 28.83% and 28.62%, and the last one is 45.76%. The results of the percentage inaccuracy is pretty evident, and we can assume that some errors occurred during the experiment. And to avoid these errors that may affect our accuracy of the reading, we should take several precautions. Also, water velocity is related to the height of the original water level, and according to the theory, the velocity of water, on the other hand, is growing while the beginning water level is decreasing. And according to our experimental findings, we assume that certain errors occurred because the experimental outcome contradicts the theory, and the experiment should be repeated to ensure that all of the variables have been taken into consideration. That's all from me. Thank you.